Good morning and welcome to Friday's video for Year 6. We are going to look at reading and interpreting line graphs. So the answers from yesterday. This was the original one, however Amir had got it wrong. This is the correct one. Now, explain one mistake he made. Well, here it says he goes for a walk. He walks for half an hour before stopping and resting. He then jogs 2 kilometres back to his house. He rested. Now, this person's got confused. Having a flat line is correct. However, this axis here is about distance travelled. Now, if you put the point here, you're saying that he's travelled 0 metres from home. So what he's actually done on this graph is he's gone for a run. He's somehow transported through time and space and arrived back at home, had his rest on his sofa at home, then somehow magically teleported back to where he was, and then finished his race and gone home. Now, personally, if I could teleport, I probably wouldn't bother with that in the first place. This is the correct graph because he has done his running, stopped, hopefully socially distancing on a park bench for a bit, and then run home. Within his hour of allocated time. Well done, Amir. You've done well. Next graph. We're losing the plot.
We are.
So, this is your story of a hot air balloon. So you had up the side, height above the ground, then time of the journey. So the hot air balloon starts from the ground at 0 minutes. Hopefully you knew that your first point went here because it hasn't left the ground yet and it is 0 minutes. So your first point should have been there. Then it rises steadily. It then gives you a clue that after 15 minutes the hot air balloon is 500 metres above ground. So you know that your first point is going to be 15 minutes and 500 metres. And it's rising steadily. It doesn't say that it's jumping all over the place. It's a steady rise, so it's a steady line. Then it stays at that height for 10 minutes. Keyword, stays at that height. It doesn't jump back down, it stays at the height. Then it gradually rises again, so then you have to go, you work out for how long, 15 minutes, find your 15 minutes, and then find 750, plot that, and again, a steady line because it's steadily rising. Then again, it stays the same, so your line plateaus at that height. Then it says it for the remainder of time, it gradually returns. Now you know that it was 60 minutes, your graph ends at 60, so you just do a line down to 60. Well done if you got that, it's really cool.
Beautifully explained.
Extra points if you drew a nice little hot air balloon. So, Fluent in 5, pause the video and have a go. So, hopefully you pause the video. 81 times 2 is 162. 33 plus 8 times 2 is 43 because you would have had to do this section first. 43 times 32, 1,376. 654.85, take away 84.89 gives you 569.96. 0.49 divided by 0.07 gives you 7. And 54 times 0 gives you 0. Please let none of you write 54. When you multiply by nothing, you always have nothing. Right, today's first problem. This graph shows the distance travelled by a cyclist. What is happening at the point showed on the arrow? So you've got your time here and your distance travelled here. Then you've got your options. At this point here, has the cyclist stopped? Is the cyclist riding slower, or is the cyclist riding at the same speed? Second graph. This graph shows the speed of a 400 metre runner. What is happening at the point showed by the arrow? So you've got your speed in miles per hour and your time in seconds. Then this point here is the runner's fastest speed, the runner finishes, or the runner slows down. Think carefully about both of those. Then, as it's Friday, we're giving you the answers. So, here, the cyclist has stopped. Now we know this because the miles doesn't increase, but the time does. So time is still ticking by, but he hasn't moved. He stayed in the same distance from home. So it plateaus for a little bit, and then you can see here that his distance starts to increase again, so he's set off again. But at this point here, he's stopped. This graph, the runner begins to slow down. We know that because the curve is going down. However, it's not the runner's fastest speed because actually it's not the highest point of the curve. So at that point, the runner is slowing down. Well done if you got those right. See you soon.
Bye.